Okay, good morning, Math 152. It's Rochelle here. I'm going to look at example 5 from the section 6.2b lesson notes. And let's go ahead and start by drawing a picture. I always want to draw a picture. So we have our function y equals 2x. I'm going to try and draw this without a scale. Okay, so we have y equals 2x. In our next one, we have y equals x cubed. I have a general idea of what that looks like. And that I just wanted to try and draw it kind of big, though. You know, it looks like this, and it will continue to go down. But it's this cantaloupe-looking shape that we're interested in the area of. And its y is greater than 0, so it's only in this first quadrant. So this is the x-axis. And this is the y-axis. And we want to revolve this about the x-axis. So we're going to revolve it this way. And so this line right here is going to be down. This blue one is really going to be kind of on the inside, because when I revolve it, you know, it is this shape right here. And so from the outside of this, almost if you tilt your head, martini looking glass, it looks like a solid shape, but there is a hole. This region right in here is a hole. So if I do a slice, if I do a vertical slice, slice is going to look like this. There's going to be a hole in the middle. And so this hole makes this whole thing, instead of looking like a disc, we call this a washer. Okay? Now, this shape, if I look at it, basically looks like this. It's got a little bit of thickness, of course. Sorry, my drawing is kind of And so let's go ahead and write our equation. Since this is a delta x here, we're going to have our volume is still going to equal the integral from a to b. And this is going to be the area function, the area for this washer, with respect to x. Now it's obvious right here, if I look at it, that my point starts at 0. So my a value is going to be 0. However, it is not obvious what this value is going to be right here. I didn't even draw a scale. So we're going to need to find this intersection point. I'm going to try and do the work right here, where we're going to set x to the third equal to 2x. Now if I move that onto one side here, minus 2x equals 0. Whoopsie, that should be a 3. Ooh. And then I factor out an x. I will have x squared minus 2 equals 0. Now you'll see that x could be 0. And x squared minus 2 could equal 0. Now if I solve this, x squared is going to equal 2, which means that x is going to equal plus or minus the square root of 2. But since we're in the first quadrant, we only care about this positive value. So this value here happens to be the square root of 2. So if I go back over here, this is going to be this is going to be the square root of 2. 2! And my area function for this, I'm just going to write it here, is going to be pi r squared. Now this is going to be the outer circle. Is that spelled with 2 T's? Ugh. Minus pi r squared for the inner circle. So I like to call this in and this out. So I'm going to have pi here, my r squared for my outer circle. Now my outer circle, if you notice, my outer radius, which would go from here all the way down to the middle, that would be this radius right here, is going to depend upon my line function. And my line function had the equation y equals 2x. So this is a y height, and that y happens to be equal to 2x. So this is going to be a 2x here, dx, and that's going to be squared. And then we're going to subtract. This is going to be my inner radius squared. And this is still going to be a dx. Now, well, I guess I didn't need to put the dx here now, did I? I'm going to go ahead and erase that and just put parentheses here, so it's all dx. Apologize for that. Now the inner radius is based on my blue function here. My inner radius is right here, goes from here to here, and that's dependent upon y equals x cubed. So my inner radius is a y value, but that y value is equal to x cubed. And so this is the integral that I'm going to want to evaluate. And that's the hard part, though, is getting that set up, of course. So we're going to have 0 to square root of 2. And then I'm going to go ahead and pull out the pi out in front here since there's in common. And so then I'm really going to have here 4x squared minus x to the 6th, which is something that is, you know, pretty easy to integrate. So I'm not going to show that work right here. The work you can find in WAMAP. But that answer, I'm going to go ahead and just give you that answer. I'm looking at my notes here. That answer has a bunch of square roots in it, but it's approximately equal to 6.77, and that's units cubed. Again, if you want to do the work from here to here, I would do that by hand, but then you can check your answer online in WAMAP where I have it posted. So that's our first washer method volume. Alrighty, let me go ahead and end this.